السلام عليكم ورحمة الله. لعل الجمهورية الإسلامية في إيران تستثمر منذ زمن في أبحاث الخلايا الجذعية، وعلى الرغم من محدودية الوصول إلى معدات المختبرات ومواردها، فقد كرست إيران مكانتها كقوة علمية يحسب لها حسابها في مجال الخلايا الجذعية. مع الدكتور نصر-Esfahani مدير مركز أبحاث الخلايا بمعهد رويان في أصفهان، نتحدث عن أحدث إنجازاتهم الرائدة في هذا الحقل من الداخل. معكم زينب صفار، تابعونا. لعل إيران تعد واحدة من أكثر الدول ريادة في العالم والثانية في المنطقة استناداً إلى المعرفة والتكنولوجيا والاستثمار بالخلايا الجذعية ولا سيما البشرية الجنينية، وفي هذا المجال من الأبحاث وأيضاً في قضايا الخصوبة والاستنساخ تنشط العديد من المعاهد والمراكز البحثية في العديد من الجامعات الإيرانية. أما في معهد رويان، وهي كلمة تعني جنين بالفارسية، الذي أنشئ عام 1991 كعيادة للعقم، فتجرى العديد من الأبحاث حول الخلايا الجذعية. وبالرغم من أن العالم يركز انتباهه على تطوير البرنامج النووي الإيراني وما يدور في فلكه، فقد تقدم العلماء الإيرانيون نحو الطليعة في أبحاث الخلايا الجذعية الجنينية والخصوبة والعقم، ووفقا للدراسات فقد قاموا بخطوات كبيرة واسعة في هذا الحقل. ولكن في ظل العقوبات القاسية تواجه هذه الميادين العلمية لخدمة الإنسانية عددا من التحديات، مثل الصعوبات في استيراد المواد والكواشف. دكتور محمد حسين نصر-Esfahani مدير مركز أبحاث الخلايا في معهد رويان في أصفهان، والمتخصص في مجال علم الأجنة السريري، الذي قام بالعديد من الأنشطة في مجال استنساخ الحيوانات والخلايا الجذعية وعلم الوراثة، وقد سجل دوره كمسؤول مشروع استنساخ الأغنام لأول مرة في الشرق الأوسط فصلاً جديداً في العلوم والمعرفة في الجمهورية الإسلامية في إيران، يشرح من الداخل حال العلاج والأبحاث في معهد رويان.
As you are aware, Royan Institute is made of three sub-institutes. One is Institute for Stem Cell, one is for the reproductive biology, which is infertility, aimed on infertility, and one is biotechnology, which is based in Isfahan. Therefore, the one in Tehran on stem cells, they work on mainly on stem cells and clinical therapies, and now they are providing cell therapy to Iranian and also tourists who come to Iran. The Infertility Center in Tehran is one of the biggest infertility center in Iran, and it's also providing the whole range of infertility treatment, and also they are doing research both on stem cell and both on infertility. I'm mainly based in Isfahan in the Institute of Biotechnology. We have around 5 to 6 sub-departments in our institute in Isfahan. The one which are very famous for is our embryology department, which we have been able to do the first cloning in Middle East, and most of the Middle East and world know as well for our cloning.
And thanks to you, of course.
Thanks
for
to
your efforts, of course, the
thanks
team.
Thanks to the team and
Sure.
Allah who has given us such an opportunity. But so people, we've been working in here on cloning, and the achievement has been very fantastic, and
Sure.
everybody knows this institute, and also Iranian people know this center as a center for cloning. We are also working on infertility research because I'm associated with an infertility center in Isfahan, and also we have large amount of research on infertility, especially on sperm. And so mainly people with male infertility are referred to our center.
Is it only research or also treatment?
No, it's treatment, and besides the research has developed new approaches in the treatment, which has welcomed many of the patients to
Amazing.
come. Then we will come to each of them, but we just summarize. Then we have a small stem cell department. We are mainly focusing on regeneration of the eye parts of eye organ, as like the retina and things like that. And then we have also a small unit which produces recombinant proteins. And then we have a genetic group which mainly focuses on diabetes at the moment, and food and exercise, how food and exercise can affect our diabetes, our health. And then we have another group which also work on nanotechnology. We have about 6 to 7 PhD in engineering who are working as an academician in our center, because we believe that the multidisciplinary approach is the is the way to advance. So these are the groups. But if you want me, I start with the cloning. But if you have any question, you are welcome to ask.
Yes, I will ask you further about the details of cloning. But if you want to explain to the people in the simplest forms, when you talk about stem cells and so on and so forth, and in the treatment of disease, what does that mean? Okay. How can we understand it?
Let's differentiate about a normal cell and a stem cell.
Exactly.
With the normal cell is called somatic cell, and the stem cell is called a stem cell. A normal cell or somatic cell, only when it divides, it produces itself and no other cell. For example, our fibroblasts in the skin, when they divide, they produce fibroblasts.
The same, okay.
So they are unipotent. They can only replace one type of cell, and that is themselves. When we talk about a stem cell,
so it's a plethora of cells.
Yes, exactly. Not only it renews itself, it is able to produce different plethora or different type of cell. Therefore, it is able to differentiate to numerous type of cells. Therefore, they are called pluripotent, or they are able to produce different type of cells. For example, an embryo or a zygote after fertilization is able to produce not only our body but also the placenta. The cells 5 days later within the embryo can produce only the body of the embryo and not the placenta. And as the different cells differentiate through development, their pluripotency, their ability to produce different type of cells is reduces. So we have stem cells in our body, different points. We have stem cells in our bone with a limited ability to produce. And therefore we have stem cells in the embryo with ability to produce all type of cells. So the advances is to use a stem cell from embryonic, which we can treat many diseases. For example, we can differentiate embryonic stem cells to neural cells, and maybe one day treat spinal cord injuries. Or we can differentiate a stem cell to neural cells, neural precursor cells, and
brain damage,
brain damages, or if different brain associated disease. We can develop embryonic stem cells, for example, for bone regeneration. We can develop embryonic stem cells, for example, for eye regeneration. But we are using, for example, a stem cell from a skin to treat skin diseases. And for example, if you have a scar, if you have a vitiligo, we are doing treatment, taking normal skin, propagating the cells, transferring to the affected area. For example, if a lady has a scar on her face, it's affecting her beauty, it's affecting her marriage, it's affecting her social life. We are able to cure that.
Bless your heart. Thank you.
And give them a healthy life and healthy.
Yes. How pricely is it? How costly is it? Is it highly priced?
I think it's at the moment is about maybe $2,000 to $1,000 for a skin treatment, which is not much for.
Exactly.
Not at all.
Exactly.
In Iran, the treatment of the medical treatment, the prices are very low because the government wants it to be everybody to use it.
The prices are low and the quality is excellent. Actually. And here I would like to just talk briefly, perhaps, sir, about the human embryonic stem cell research, which is surrounded by moral and ethical debates. In Iran in 2002, while American scientists at that time were stuck in an epic political debate over the cell's use, Iranian researchers had a green light to launch various experiments, develop cell lines, and invent novel therapies. And they say that Islam, it is very compatible with the modern sciences.
Exactly. Islam believes that any research which is beneficial for human society and for human being should be allowed. And the research has two sides. A good side is like a double-edged sword, a good side and a bad side. We should prevent its bad side, misusage and things like that. But since stem cells brings health and happiness to society, they allow it. But also we have to remind that we have ethical committee, we have restrictions, we cannot do anything that we want. Everything that we have to do, we have to write project, we have to get ethical committee permission, we have to pass legalities, laws. Things are allowed, but within limitations and laws.
Within limits, yes.
And the overall statement by the state, and especially the religious state, is that our, in simple word, our part, like a machine part, should not be completely turned to a complete human. We can repair somebody's heart, we can repair somebody's skin, but we should not think of cloning or producing a whole human being.
Yes.
This is
very progressive because it is very much pro-human to help the humanity, but at the same time, we're not taking the role of...
This is the abuse of this technology.
Exactly.
So we are allowed to use the research for benefit of a society, but we should stop its limited. What we are limited to is abuse.
Exactly, sir. Allow us, Dr. Nasr-Esfahani, to stop for a short break, and then afterwards we're going to talk about Royana, which is the first cloned sheep in the Middle East and in Iran.
But let me just tell you that we are now have a stem cell therapy in Royan Institute in Tehran for bone regeneration. They have a stem cell institute for arthritis, especially for knee, which is, and they have a stem cell regeneration for many of the different treatment. People can refer to our to Royan Institute research site and to clinical section and see the different type of treatment that we provide for the Iranian and also for the visitors who would like to come and get treated in Iran.
Thank you, sir. Allow us to stop now for a short break. إذا فاصل قصير ونعود، لا تذهبوا بعيدا. رويانا هو الاسم الممنوح لأول شاة مستنسخة في الشرق الأوسط، ولدت في 30 من أيلول سبتمبر عام 2006 في مدينة أصفهان الإيرانية. دكتور محمد حسين نصر-أصفهاني مدير مركز أبحاث الخلايا في معهد رويان حفر بصمته على مشروع استنساخ الحيوانات هذا، وأحرز موقعا رياديا ومكانة لإيران في المنطقة برمتها في مجال العلوم والتكنولوجيا. يخبرنا بعض التفاصيل عن هذه الخطوة.
Let's just remember our past beloved Dr. Kazemi Ashtiani, who was the founder of the Royan Institute.
Bless your heart. Sure.
When he was, I came to know him, and he just established Royan Institute. One of the projects he wanted to do was to produce a stem cell through cloning, because if we want to transfer cells to body, we should prevent rejection. Like the kidney, we have to have matching. So he wanted to produce a stem cell from people's own body so that to prevent rejection. So one way to produce embryos through cloning, and they make stem cells from cloning. But then it came the technology of IPS, which was it also won the Nobel Prize between the UK and Japan, and therefore this technology, its efficiency and its use in a stem cell was reduced. But little by little, despite its hope of using it in a stem cell technology faded away, we started to work on this technology, and we increased its efficiency. And at that time, when the first cloning was born in the whole, the dolly, the chance of birth was 1 in 1,000 embryos, nearly less than 1%. Now we are doing cloning with 30% efficiency per transfer. This means that in 100 goats, if we transfer 100 to 200 embryos to 100 goats, we get 3 live clone goats.
Yeah.
And this is excellent result. Everybody knows in the world.
And recognizes.
Recognized,
sure, yes.
and well recognized. And now in Iran, the government has put emphasis in improving our agriculture and also the dairy product. We want to increase number of the elite goats, sheep, and cow. And this technology can produce the elite animal. One elite goat only can produce 2 offspring per year. Through this technology, we can make hundreds of elite animals, and therefore it improves the efficiency or the benefit or reproductivity of dairy farming in Iran. So now that the technology has become improved and efficient, we produce cloned goats, and we will sell them to farmers, and farmers come and buy from us, and through these procedures we've been able to improve.
Are they healthy?
We have now,
just as the regular?
No, we have now 10 generations of them. For example, the clone goat has given birth to
others,
yes. And their children has given birth. We have nearly 10 generations coming from the goats that we have cloned.
You have cloned. Bless your heart, sir.
So this means that there is no worries about the quality of it.
And no side effects and no nothing.
Well, cloning has side effect, but the rate of abnormalities in clone goats are a little bit higher. But since we have made them efficient, that has also decreased. So we are efficiently producing clone goats. Farmers want from us, and we sell them, and we have a big farm which we have now producing clone goats. When you come to our farm, you see Sanan, which is white, but you see also hundreds of domestic goat, which we transfer the embryos from the embryo to these, and they will give birth to Sanan goats, and the people come and buy it. So you will see Sanan goats, and you see domestic goats, which are the carrier of the embryos of Sanan goats.
Yes, Your Excellence, Dr. Nasr-Esfahani, is not only in cloning, but also in the issues of infertility. And the Asfahan Royan Institute is certainly at the cutting edge as it has achieved a new method of treating infertility recently. Tell us about this new breakthrough method.
When I was in UK, I worked with Professor Johnson, who was the student of Bob Edwards. So in terms of history of infertility, I'm the third generation. Bob Edwards, the founder of the first IVF.
Yes.
Martin was his student, and then I was Martin's. So
it moved on to you.
It moved on to me. And since then, I've been very interested in infertility. And when I came to Iran, I was more interested in male infertility. Therefore, when I was working as a clinician, as embryology in my hospital, I found many patients coming and they have a bad sperm and they are not. So I introduced approaches like artificial oocyte activation. When a sperm enters the oocyte, it activates the oocyte. And some sperms, when they enter the oocyte, they cannot activate it. This was pioneered outside Iran, but I first started it in Iran. Then I started it in patients like globozoospermia, special patients which don't have an acrosome, special genetic anomalies. And I have a record of high pregnancy in globozoospermia. We've reported it in the journal of RBM Online, reproduction, and it belongs to a UK. So from all over Iran, patients regarding globozoospermia come to our center to get treated. Also, artificial oocyte activation was used for patients who had a low fertilization. So we improved the rate of fertilization, we improved the production of embryos, increased the number of embryos per insemination. Therefore, the chance of pregnancy was improved in the patient. I also, in nature, among million sperm, one gets fertilized.
Exactly.
So there is a natural selection barriers. After a sperm enters a female body, among million, one is selected. But when we, in the lab, using one sperm, our only selection is the specialist eye who look at that sperm, and that is not enough. So I invented, or I set up, a sperm selection procedures. I set up a sperm selection procedure based on the electric charge of the sperm surface. I set up a sperm selection procedures on ability of a sperm to respond to a hypoosmotic solution. These are a little bit medical, but I set up different sperm selection procedures. So I choose the best sperm, and then I inject the oocyte with the best sperm. Therefore, the chance of fertilization, the quality of embryo, the chance of feasibility of the embryo, and the chance of pregnancy is increased.
Yes, Dr. Muhammad Hussein Nasr-Esfahani, Director of the Cell Research Center at Royan Institute. Many thanks indeed for joining us, sir. People like yourself, you really make the world a better place. Thank you.
Thank you very much. It's our duty to do what we can do for any human being.
Thank you very much, sir.
Thank you.
إذا لقاء جديد في الأسبوع المقبل مع ضيف جديد وقضية جديدة ودائما من الداخل. للمزيد من التواصل بريدنا theinsight@almayadeen.net وصفحتنا على الفيسبوك من الداخل. من كل فريق عمل البرنامج من كل الميادين من أصفهان. السلام عليكم ورحمة الله.